Alright, so I tried something a little different today. I went ahead and pre-wrote all this stuff down, so hopefully this will make the video go a little faster. Over on the side, you'll see what page number I am located at so that I don't have to keep saying it, so please make sure you keep up with where we're at in the book. I am going over these problems, and they are located in your book. So here we go. First thing, let's go back to middle school. Let's talk about multiplying fractions. You do, when you multiply fractions, you do top times top and bottom times bottom, but what I like to do personally to keep my numbers small is before I multiply across, I see the rule is you can simplify anything as long as they have a factor in common. The rule is one has to be in the top and one has to be in the bottom. So if 2 and 15 have something in common, I can simplify those numbers. Well, 2 and 15 don't have anything in common. But 2 and 8 have something in common. And remember, the rule is one has to be in the top and one has to be in the bottom. The reason I'm saying that is later on, it doesn't matter if there's 3 fractions or 4 fractions. If the numbers in the top have something in common with a number in the bottom, it doesn't matter if it's the 4th fraction way over here, you can simplify those. Now, just make sure we're careful in this is because this is multiplying. Yesterday we did adding and subtracting, total different rules. For multiplying, it's real simple. You can cancel or you can simplify anything that has in common top and bottom, and then once you simplify, you multiply top times bottom. So here we go. Or top times top, bottom times bottom. The 2 and the 8 have something in common, so this can cancel out. Actually, I'm going to write a different color. This cancels out, becomes or simplifies to a 1 because 2 goes into it 1 time. 2 goes into this 4 times. The 15 and the 5 have something in common. 5 goes into this once. 5 goes into this 3 times. And then I multiply 1 times 1, which is 1 over 3 times 4, which is 12. 1/12 would be my answer. Now we apply this to some of these nastier things. But, again, I look for top and bottom. What can they have in common? Now, technically, this x and this x can cancel out. But I see that this x squared and this x squared would fully cancel out. So I would actually go ahead and cancel these guys out or simplify them. They just undo each other is basically what's happening. This 2 and this 8 still have that 2 in common, so this becomes a 1, this becomes a 4. This becomes a 3, and this becomes a 1, and so on the top I'm left with 1 times x times 1, so I have 1x or just x, and 3 times 4 is still 12, so it becomes x over 12. Alright, so here are some more examples. All we're going to do is a bunch of examples on this. Alright, so again, look for top and bottom having anything in common. Does this have anything in common with this? No, it doesn't. Don't always just look right across from each other. Look top and bottom straight up and down from each other. This one and this one. Sometimes they do that to try to trick you. Make sure you're checking here and here. Nothing in common. Here and here. Yes, they have a 4 in common. 4 goes into both of these. It goes into this 3 times. It goes into this 2 times. Notice you're going to be crossing a lot of things out. So again, space your workspace out on your paper so you have room to write. Don't try to smash this into one tiny little line. Write big. Like I said, kill trees. If you want to, recycle. I encourage you to recycle. But for math, please, take the paper and the space. If you need more paper, ask mom, dad, me, whatever. I don't care. Just get some paper. Work this out. Don't try to cram it into one. Not only do these have 4 in common, but they also have a z. Now this has 2 z's. This only has 1. So this is completely gone away. Now I only take one of these away, so it now becomes, instead of z squared, it just becomes z. Now, this has nothing in common with this anymore, and this has nothing in common anymore over here. So now I check, does this have anything in common with this? Well, yes it does. 11 can go into 11 once, 11 can go into 33 3 times. And then I multiply all my things across. Now, I want to multiply my numbers together. So 3 times 3 is 9. And then I get x times x. So what I do is I always do like terms. X times x can become x squared. So that's gone, and that's gone, that's gone, that's gone. Notice I mark things off. And then I have a y and a z left over. So I get y, z. Over 1 times 2 is just 2. Now there's one thing I should have talked about before we did this. Before we cancel things out, we need to look at restrictions. So actually I need to erase this. And remember I canceled out a z. X, y, z. Well, when I canceled that z out, it was in the denominator, which is huge, because if z was 0, it would make all of this work worth nothing, because this would become undefined, and then I wouldn't be able to do any of this. I wouldn't simplify anything because of this one problem. So I have to put over here my restriction, wait, z is not allowed to equal 0. So you need to find your restrictions before you cancel things out. And we obviously, hopefully, kind of think about this. Since it cancels out, it's going to be that hole that we talked about. But this is a much different application with it having 3 variables. Don't worry too much about that, but make sure we do understand the restriction. Z is not allowed to equal 0. All right, and we're just doing a whole bunch of these practice. Look, top and bottom, and now before I do this problem, one thing I want to do is I want to make sure they're factored, because factors are going to cancel out. This guy's not factored, this guy's not factored. So remember I told you, beginning of chapter 8, you're going to have to factor before you can even really start the problem. So I'm going to factor those guys. So I'm going to rewrite this as 5x squared over, these guys have they have a common factor. 3 goes into both of them. So I pull out a 3, and I'm left with x squared minus 25. But even when I do that, I go, wait, this is a difference of squares. So I'm going to actually factor it again, and it's going to become 5x squared over 3x minus 5, x plus 5. You have to make sure you completely factor it out. Just because I do it once doesn't mean I can't factor it again. Yes, I pulled out a greatest common factor, then popped out a difference of squares. So this problem is now, this has become this guy right here by factor. And I factor the top of this guy, and I pull out a 3, and I'm left with x minus 5 over 4x squared. All right, a lot of stuff is going to cancel here, so I'm going to take my time. Before I do my canceling, actually, I'm going to think about my restrictions. What would make my denominator 0? X is not allowed to equal, we're right here. It can't equal 5, can't equal negative 5, so plus or minus 5. X can't equal 0, so I'm going to put that there. So I got those restrictions. That I'm going to want to keep in mind. Now I go ahead and think about, okay, let's go ahead and cancel or simplify some stuff. Over here, this guy's got an x minus 5. This has an x minus 5. Because they're both in parentheses, it has the full x minus 5, x minus 5. These guys can cancel. We have a 3 that this has and this has. So we simplify that. We have an x squared up here. We have an x squared down here. Those guys can cancel. 5 can't cancel out with anything. 4 can't cancel out with anything. So what I'm left with on the bottom, what I'm left with on the top is 5 over, because 5 times this all turned to 1, 1, and 1. So it's just 5. This turned to a 1, a 1. I've got an x plus 5 and a 4. So what I do is I put the 4 first, because remember order of operation or multiplication is commutative, so I can switch the order. So I put the 4 first, and then x plus 5. And that would be my final answer with x can equal plus or minus 5 or 0. Alright, I'm going to roll through these a little quicker now. We're just going to start crossing things off and simplifying. 4 and 2 have something in common. 1 and 2. This has a c in common, but it only has 1, so I can only get rid of one of these. And actually my restrictions are what I want to do first. So C and A, actually A, B, and C are all not allowed to equal 0, because that would make it 0. Any of those make it the bottom 0. So that's my restriction. So I want to think about those first. Now I go ahead and just start crossing things off. 3 and 27 have something in common. 3 goes into 3 one time. 3 goes into 27, 9. A has something in common with A. B cancels out or simplifies with B. And then I'm left within the top just C over 2 times 9, which is 18. And sorry about that. When I wrote this problem wrong, there was an error. So this should have actually been b squared, which changes this. Sorry about that. Since this is b squared, only one b would have canceled out or simplified. So I'd have b up here also. So it'd be bc. Sorry about that. Change that. That's my fault. All right, rolling right along. Again, I need to factor these guys. So this guy's not factored, so I want to pull out a 5 that they have in common. So this actually becomes 5, and then x minus 3. That's going to be big for me. I think about my restrictions first, and I kind of write them somewhere on my paper so I can remember them. Because actually my restrictions should go right here. A, B, C cannot equal 0. It needs to be part of my answer. So I write my restrictions somewhere on the side or by my problem. And we're going to write it right above it so I can help remember it. So x cannot equal, it's not allowed to be 3, and x cannot equal 0. So those are my restrictions, and now I can just start crossing stuff off. An x minus 3, an x minus 3, a 3 and a 9. This becomes a 1, this becomes a 3. This has 1x, this is fully gone. This has an x left over. So in my top, I am only left with 1, because all this simplifies to a 1, and 1 times 1 times 1 is just 1. And then in my bottom, I'm left with 5, 3, and an x. Don't forget that x. So 5 times 3 is 15x, with my restrictions being x is not allowed to equal 3 or 0. Again, first thing I need to do is factor these guys. So this guy needs to be factored and this guy needs to be factored. That's factored, that tops are both factored. So I go, okay, how can I factor this? Same signs, both negative. X and x, and two numbers that multiply to 3 but add to 4, 3 and 1. And then I see that I have an x minus 3 and an x minus 3. Those can cancel. Factor this guy, pull out a 4, and I'm left with x plus 5. Now make sure the big rule is one has to be in the top and one has to be in the bottom. Let's pretend this was an x minus 1 and this was an x minus 1. These two can't cancel out because they're both in the bottom together. These guys, x plus 5 and x plus 5, can cancel because one is in the top and one is in the bottom. And please, just because this has happened twice in a row, I want you to make sure this doesn't always turn the numerator into 1. Sometimes you're left with other stuff. Look at problem A, but just remember, it doesn't always turn into 1. Sometimes it does, so that's fine. And then on the bottom, what I am left with is a 4 times the quantity, x minus 1. And I forgot one thing, and I'm bad at this because I'm trying to hurry to get through this. I need to make sure I do my restrictions. So if I look at my restrictions before I cancel it out, I can still see them. That was a 3. It was a minus 3, so it's 3 would make it 0. That's a minus 1, so 1 would make it 0. And that's a plus 5, so a negative 5 would make it 0. So my restrictions would be x is not allowed to equal, and I like to put them in order, negative 5, 1, or 3. All right, so problem D. Please do not freak out like kids tend to do just because the problem gets longer. It is the same process. You can cancel out if something has something in common with it in the bottom as it does in the top. Now, the problem with D is we got a lot of factoring and a lot of different types of factoring. So I'm going to go a little bit slower since I'm doing pretty well on time on this one. If I look right here, they have this one right here is not factored. They have a greatest common factor, which is 7, and then I'm left with an x minus 1. This one I'd want to save a lot of space for. This one right here is very tricky because, yes, I can pull out a 9, but when I pull out a 9, I'm left with x squared minus 1. This is a difference of squares. So that is supposed to turn into 9, x plus 1, x minus 1. Okay, so that's the final one. Then this guy needs to be, I can double bubble right away since it is a 1 up front. I told you guys there's a lot of factoring in this, and you got to know your factoring. Different signs. When they subtract, they need to subtract to a negative 5. So I need x plus and x minus. Two numbers that multiply to 6 but subtract to a negative 5 would be 6 and 1. The bigger number is negative, so the 6 went with there, and the 1 goes there. These guys, before I can go ahead and double bubble, I need to pull out a greatest common factor. They all have an x, so I pull out an x. And what am I left with? X squared plus 6x plus 5. Now I try to factor this. And so my final factor becomes two same signs, both positive, two numbers that multiply to 5 but add to 6, 1 and 5, x and x. So now before I would start crossing things off, especially with a big old problem like this, I want to make sure I don't make my mistakes. I want to do my restrictions. X can equal, from this one right here, just 0. Moving on. X can equal plus or minus 1. And from this one, I already have the negative 1, so I don't have to include it again. I already have the 0, so I don't have to include it again, but I need the negative 5 from this one. So there's my 4 restrictions on this problem. So then I start crossing things off, and I say, okay, remember, it does not have to be right over each other. This right here, it could cancel with something out over here. It doesn't, because I don't have an x minus 1 and an x minus 1 over here. But it could. So don't think, remember the rule is one has to be in the top and one has to be in the bottom. It doesn't have to be right next to each other. So it doesn't have to be x minus 1 and x minus 1. This x minus 1 could have been over here and it would have canceled out. Hope you're understanding what I'm saying. But this x minus 1 and this x minus 1 cancel out. This x plus 1 and this x plus 1 can actually cancel out. They're right over each other. This x plus 5 and this x plus 5 can cancel. So in this, if I think I only have a 7 left here, I've got a 1 left here, and I just have an x minus 6 there. Over here I have a 3x squared, I have a 9x plus 1, and I have an x. So I think that's it. So what I do is I go, okay, on my top I'm left with 7x minus 6. And on my bottom, I'm left with a 3x squared, and this x can actually, and actually this 9. So what I can, let me back up. What I can do is I can go, okay, all the numbers, let's multiply all the numbers. 3 times 9 is 27, so I get 27 done. And then I say, okay, let's do this x squared, and this x can combine to become x to the third. And then I'm going to times that by the quantity x plus 1. And I've used, so I used my 7, I used my x plus 1, I used my 3, I used my x squared, I used my 9, I used my x plus 1, I used my x. So everything's crossed out, I've used it all. Now in the book, they give me a different answer. That's because they actually distribute this. If it's not a multiple choice test, I am fine with this being the answer. If it is a multiple choice test, you're going to have to know the book answer is actually this. 7x minus 42. Again, all they did is distributed the 7. Here, they're going to distribute the 27x cubed. And so up front, I'm going to have a 27x. When I do x to the third times x, it becomes x to the fourth. And then when I distribute this times a 1, it becomes plus 27x to the third. And that's the book that gave me, with the restrictions being x cannot equal 0, plus or minus 1, or a negative 5. That is my final answer. Do not freak out on these. Alright, last section is very quick. We're going to go fairly quickly through this because it's the same concept. Do we divide with fractions? No. What we do instead is we keep the front number the same, change this to multiplication, and do the reciprocal. And then we can do what we just did, where it's multiplication. Does this have anything in common with this? No. Does this have anything in common with this? No. Does this have anything in common with this? Yes. And I can simplify the 10 to a 2, and this becomes a 1. 1 times 2 is 2, over 3 times 1 is 3. And we're going to do that same thing, which is nastier numbers. I'm only going to do 2 of these problems because I want you can try A and B on your own. Maybe at the end I'll put the answers up. But the first thing I would do is I would factor again, because we need to make sure. The only thing different is so we actually have to look. The only tricky thing about this, guys, we have to look at its restrictions twice. Other than that, it's fairly simple. But you have to look at the restrictions twice. So what I do is I first factor all these guys. So the first thing I'm going to do is factor this, and factor that. That's already factored. So I go, okay, what can I pull out? I can pull out a 3x for my top. They both have a 3x in common. And then I'm left with x plus 5. So that's this right here became here. Now I'm going to factor the bottom one. And if I factor this, it becomes, I can double bubble right away, x, two numbers that multiply to 40, different signs, so they're going to subtract to a 3. So those numbers would be 5 and 8. And the bigger number is negative, so it would be plus 5 minus 8. Now I'm going to leave this as divide for right now. 5x squared over, this is the difference of squares, x plus 8, x minus 8. So I have to look at the restrictions right now. So that's my first time. So I look at the restrictions now, and so far I've got x is not allowed to be negative 5. X is not allowed to be positive 8, and actually over here I get negative 8 also. I already have the positive 8, so I don't need it twice, so I can put plus or minus 8. So far those are my restrictions. Now, if you remember what we did last time, we keep this number right here, keep that, change this to multiplication, and flip this over, do the reciprocal. So it's going to look like this. 3x, x plus 5, keeping this the same, over x plus 5, x minus 8, and I'm going to times it now by x plus 8, x minus 8, over 5x squared. Now I need to do, once I switch this, I need to see, are there any new restrictions when I flip it over? Negative 5, I already had that restriction. Positive 8, I already had that restriction. But now, it's not allowed to equal 0. And so I have to add that restriction in. So I have to put, wait, there's another restriction. It's not allowed to be 0. So that's the second time I look at restrictions. Now once I've done my restrictions, I can start crossing things off. X plus 5, x plus 5. X minus 8, x minus 8. There's an x here. There's 2 x's here. So one of this is gone completely. I'm left with one down there. And so when I see, okay, what do I have left? Up top, I only have a 3 here, and I have an x plus 8. So I have 3 x plus 8. That's taken care of, and that's taken care of. Over, and my denominator, the only thing left I have is 5x. And my restrictions, don't forget to write your restrictions right next to it, are x cannot equal, and again I write them in order, negative 5, comma 0, plus or minus 8. And that would be my answer. Alright, last one. Again, don't freak out because this thing has 3 problems on it. I'm going to do the same thing. So take your time, first off, and factor these guys. The top is done. The bottom is not factored. What do these guys have in common? This and this have a xy in common. What am I left with then? Xy minus 1. Don't change this yet to multiplication. Difference of squares, x plus 2, x minus 2. I'm doing all these examples for you so you have different ones that you can see. This guy right here is a pain in the butt. I can't pull the 3 out because they don't have a greatest common factor, so I got to go the long way. So you know what? I'm going to go over here on my scratch paper and do some side work. So I've got 3x squared plus 19x minus 14. 3 times 14 is going to be 12. 42. So 42, I need 2 numbers that multiply, subtract, right? Different signs. So 2 numbers that multiply to 42 but subtract to 19. 21 and 2. So my two numbers are going to be 21 and 2. So I got 3x squared. Bigger number is positive, so I'm going to put the minus 2x first, plus 21x minus 14. I factor by grouping. What do these guys have in common? Just an x. And I'm left with 3x minus 2. What do these guys have in common? A 7 plus 7. What am I left with? 3x minus 2. What do both bubbles have? A 3x minus 2. What am I left with? X plus 7. So this guy factors out into a 3x minus 2 times x plus 7. Then divide by, this is nice, x minus 2, xy. Now, before I do any kind of changing or anything, I'm going to look at my restrictions. So x cannot equal 0. This is a fun one. Right here, x times y is not allowed to be 1, because if x times y equal to 1, then I would do right here, if this is a 1, 1 minus 1 is 0, so x times y is a new restriction, kind of. Hopefully you understand that. So x times y is not allowed to equal 1. I look at this right here, and so you'd have to solve this one. So you have to add 2 to both sides. That would be 3x equals 2. Divide by 3, so it would be 2/3. So x is not allowed to be 2/3, because that would make this denominator 0. X can't equal negative 7. And then we already have x and y can't be 0. X times y can't equal 0. Alright, now I flip some stuff over. First one stays the same. 4x over xy minus 1 times 3x minus 2 x plus 7 over x plus 2 x minus 2. Then I change this to multiplication. Flip these guys over. This becomes xy over x minus 2. Now I look for new restrictions. Are there anything new? Well, can't be a positive or a negative 2, and I already have that, so that's x. X got a bunch of restrictions, plus or minus 2. And then now I can start canceling things off. Again, like I said, just take your time, space this out, use a lot of paper. Alright, does does 4 have anything in common? No, no, no. Doesn't x. I'm going to hold off on that because I see this xy can simplify with this xy. So I'm going to cancel that out. But technically, this x could have canceled out with this x down here. But since I saw there was an xy, I just went ahead and just canceled the xy. Alright? Xy minus 1 does not cancel out with or simplify with anything. 3x minus 2 doesn't simplify. So in this one, they did it kind of, nothing really simplified. So you're left with what you're left with. 4x, 3x minus 2, x plus 7. That's all left in the top, so I put all that in the top, over xy minus 1. Then right here, x plus 2. But when I go to write this x minus 2, there's not just 1, there's 2 of them. And remember, I have to multiply this times this and this times this. So when I multiply x minus 2 times itself, it becomes squared. And then I put all my restrictions, which are x is not allowed to equal 0, 2/3, negative 7, plus or minus 2. So x got a lot of restrictions. And also, xy is not allowed to equal 0 or 1. I guess what we can do is just say y can't equal 0. X isn't allowed to equal 0. Xy is not allowed to equal 1. And y is not allowed to equal 0. So that would be all of my answers for this problem. All right? we'll practice more on this tomorrow in class.